Welcome to the bilingual e-lectures for diploma students on linear integrated circuits. This is my 13th lecture, right. So, in the curriculum of 4th semester linear integrated circuit, electronics and communication engineering. So far in the 12 lectures, first 2 unit of the syllabus is covered, right. So, from this 13th lecture, I am going to cover the 4th unit of the syllabus, that is analog to digital conversion and digital to analog conversion. Now, let us understand the basic concept of analog signal and digital signal. What is analog signal? So, students, you must be familiar with the analog word. The word analog refers to the continuously valued signal with respect to time, right. டயத்தை பொறுத்து கண்டினியூஸாக சேஞ்ச் ஆகிற சிக்னல் வந்து அனலாக் சிக்னல், ரைட். ஃபார் எக்ஸாம்பிள், the real life, in the real life, almost in our real life, all the quantities, all the signals what we receive are analog in nature. Say temperature, டயத்தை பொறுத்து கூடலாம் குறையலாம், வேரி ஆகிட்டே இருக்கும், right. Speed, so anything in a real life signals mostly analog in nature, changing its magnitude with respect to the time, may either increase or decrease. Different time, at different time it have a different value, analog signal, that is continuously varying. For example, say watch எடுத்துக்கலாம். So, we are using the watch, முள்ளு ஓடுற watch, right. So, that is analog watch. அதில் பார்த்தீங்கன்னா minute needle continuously, minute, hour, second needle continuously running with respect to time, right. But digital means, digital watch, it shows only the numbers in digital. Okay, anyway, so analog signal is a continuously valued signal with respect to time, magnitude is continuously changing, whereas digital signal is a discrete one, right. That means it will have only 2 values at any instant of time, that is digital signal. See here, real life signal is analog in nature, right. So, like this, it varies continuously with respect to time, right, in any shape. It may be a sinusoidal, triangular, any variation with respect to time is a analog in nature, analog signal. But at discrete instant of time, you are representing the magnitude, then it is a discrete signal, and if you make it as a 1 or 0, right, that is, it is a digital signal, right. So, what about the conversion? Why do we go for conversion? What is the need of analog signal to be converted into digital domain and digital signal to be converted into analog? ஏன் கன்வெர்ட் பண்ணணும்? See, for example, I already told you all the real time signals are analog in nature. Real life ல எல்லா சிக்னலுமே analog in nature, right. So, I want, say for example, temperature variation. I want to record the temperature variation in the atmosphere, right. So, for that what I need a sensor to sense the temperature, present temperature of the atmosphere, and it may vary, but temperature varies very slowly. For that you can take another example, other example which varies with respect to time fast. So, whatever it is. So, when it varies, I can have, using a sensor, I can have the value, I can get all the values with respect to time, right. With all the variations with respect to time, I can have the value, right. But I cannot store it in a digital system, because mostly I am using a computer or a cell phone or any digital memories to store it, right. So, they operate with only binary numbers, ones and zeros. So, here I need to convert my analog signal into a digital bit pattern, so that I can store it in a memory. So, memory la store பண்ணனும்னா ones and zeros மட்டும் தான் digital memory la store பண்ண முடியும். அப்ப analog signal ones and zeros மாத்த வேணும். That is why we need analog to digital converter, that is where we need analog to digital converter. Similarly, so recorded informations I want to display or recall. So, I using analog device, or I have to present the data stored in the memory to the analog device. So, data is in digital form, but it is to be converted into the analog form, so that the analog device can receive and display it, right. So, there I need digital to analog conversion. See, for example, look at this diagram. Here I am speaking, so I have a mic here, sensor converting my speech signal into a voltage or current variations, that is nothing but the analog signal, the current varying with respect to time, right. So, it is in the analog form. My speech signal is converted into a current or voltage in the analog form, it is analog signal, but I want to record my speech in a memory. So, how to do it? So, who is my recording system is a digital system, computer. So, how can I record? So, this analog signal should be converted into a digital bit pattern. So, for that we need the analog to digital converter. Without this conversion, we cannot store my, I cannot store my speech, I cannot record my speech, right. So, definitely we need analog to digital converter to convert the analog signal into a digital bit patterns, ones and zeros. Then it can be stored into the, it can be brought into the computer. Computer can accept only the digital signal, right, and you can store or you can do processing, any processing you can do with this arithmetic signal, maybe any type of processing, right. Then you can modify your, do all the values here, and then this my stored speech should be given to the speaker, right. Speaker is analog device which receives only the continuous variation of the signal with respect to time. So, here I need to convert my digital signal into a analog signal. So, here I need digital to analog converter, right. So, of course, in our real life nowadays mostly we are depending on the digital systems. Take a cell phone, computer, players, MP3 player and televisions, mostly we are using the digital systems, right. So, even camera, digital camera. So, definitely to interface with the real time signal we need these two converters, right. This is the example for analog signal, this is nothing but the digital signal. What is the digital bit pattern? Here we are able to see only zeros and 1, that means off, 0, on, 1, that is zeros and 1s is the binary number system used to represent the digital signal. But in terms of voltage, 0 may represent 0 volt, 1 may represent 5 volt, right. So, there are different technology by which the voltage range differs, right, right. So, this is the digital signal, this is the analog signal, this is only the quantized analog signal, right. Now, we understand that why we need the analog to digital conversion and digital to analog conversion. ஏன் நம்ம analog signal digital convert பண்ணணும், ஏன் பண்ணணும், ஸ்டோர் பண்ணுறதுக்கோ டிஜிட்டல் ப்ராசஸ் பண்ணுறதுக்கோ நம்ம டிஜிட்டல் சிஸ்டம் யூஸ் பண்ணுறதுனால கன்வெர்ட் பண்ணணும். டிஜிட்டலில் ஏன் அனலாக திருப்பி கன்வெர்ட் பண்ணணும், எகைன் டு ப்ரெசென்ட் டு தி அனலாக் டிவைஸ், ரைட். லெட் அஸ் டிஸ்கஸ் ஃபர்ஸ்ட் டிஜிட்டல் டு அனலாக் கன்வர்ஷன். வை, ஏன் நம்ம முதல் டிஜிட்டல் டு அனலாக் கன்வர்ஷன் டிஸ்கஸ் பண்ண போகிறோம் அப்படின்னா, there are various method by which analog signal can be converted into a digital signal. Analog signal digital signal-ஆ மாற்றுறதுக்கு நிறைய மெத்தட் இருக்குது. சில மெத்தடில் digital DAC is used as the sub circuit, right, sub module. So, it requires as a sub module in the analog to digital conversion method. So, I think it would be better to discuss the digital to analog conversion at first, right. So, now let us discuss how to convert the digital input into analog output. So, shortly it is called as DAC. DAC means digital to analog conversion. So, a digital to analog converter takes the digital code, accept the digital input and produces the analog voltage at the as output, right. So, this is the digital to analog converter, it receives the digital input and gives the analog voltage like this, continuous variation with respect to time, continuous variation of the voltage magnitude with respect to time, voltage value டயத்தை பொறுத்து கூடிக்கிட்டே போகிறது குறைஞ்சிட்டே continuously. So, this is analog signal, right. Now, how to convert these binaries, that means digital signal, that is binary bit patterns ones and zeros into a continuous variation, that is what the discussion on DAC, right. So, for doing this we have different methods, right. So, in our for the diploma students it is limited to discuss two important circuit using operational amplifier to convert the digital bits into a analog voltage, right. So, let us discuss it. Before we discuss the circuit which converts the digital bits into analog voltage, let us understand the basic concept behind it, right, and also the some terminology, the specification of the tag, right. So, digital to analog converter circuit பார்க்கிறதுக்கு முன்னாடி digital to analog converter உடைய spec பார்க்கலாம், தெரிஞ்சுக்கலாம். What are the specifications, important terminology we have to understand, also the concept, general concept of the digital to analog conversion, right. Let us look here. Digital to analog conversion involves transforming the computer's binary output, that is nothing but zeros and ones, binary bits zeros and ones, right, into an analog representative of the binary data. See, this is our DAC, digital to analog conversion. The input is binary number have number of, it may have number of bits, எத்தனை பிட் இருக்கலாம், எத்தனை வேணாலும் இருக்கலாம். So, let it be x0 to xn minus 1, that means n number of bits. In general I can say n number of bits, எத்தனை இன்புட் இருக்கலாம், எத்தனை இன்புட் வேணாலும் இருக்கலாம். அதை வந்து நம்ம அவுட்புட்டில் கண்டினியூஸ் வேரியேஷன் ஆஃப் த வோல்டேஜ் வித் ரெஸ்பெக்ட் டு டைம், தட் இஸ் கண்டினியூஸ் வோல்டேஜ் வேரியேஷன் வித் ரெஸ்பெக்ட் டு டைம் அனலாக் சிக்னலாக நம்ம மாற்றணும். எப்படி மாற்ற முடியும், இங்கே இன்புட்டில் இருக்கிறது பைனரி நம்பர்ஸ் ஒன்ஸ் அண்ட் ஜீரோ, இது எப்படி கண்டினியூஸ் சேஞ்சாக மாற்றுறது அப்படின்னா we need another input, that is analog input, without that it is not possible. So, what is it? It is called BR, reference voltage, right. So, it is a DC voltage, reference voltage. With respect to this reference voltage only we are able to get the analog voltage here, right. Now, let us see, that means the general idea is the output, at the output we are going to get the analog voltage based on the bit pattern available at the input combining with reference voltage, right. Now, let us see how to do it. So, what are the specification of DAC? So, the important specification of the digital to analog converter, what we have to understand, we have to learn is what is resolution. Digital to analog conversion la resolution na enna meaning, what is resolution, what about the speed, what is speed, linearity, settling time, reference voltages and errors. So, these are the some of the specifications we have to understand with respect to digital to analog converters. What is resolution? That is the smallest analog increment corresponding to 1 LSB change. What does it mean? So, digital to analog converter la digital bit pattern input kudukurom, we get the analog output, right. Here we are giving a digital input and we get analog output, right. So, for example, there are 3 bit input and analog output. Here for one LSB change, what is one LSB? Least significant bit. What is least significant bit? That means which will have the least value, right? That is the weight is the least value, right? So for the one LSB is the least value in the input side. For one LSB digital input, that means only LSB is 1, all bits are 0. For this digital input, what is analog output? That is called resolution. Smallest analog increment corresponding to 1 LSB, right? That is resolution. It is also called as resolution, also called as step voltage. What is step voltage? For each step, that means at the input side we have a digital bit patterns, digital binary inputs. So binary inputs changes from LSB, it keep on incrementing towards the MSB, right, 1. So for every step of the sequence inputs starting from LSB, sequentially for every input at the output the particular amount of voltage is keep on incrementing, right? That is called resolution or step voltage. அதாவது ஒரு LSBக்கு எவ்வளவு வோல்டேஜ் வருது அதுதான் ரெசல்யூஷன், அதான் ஸ்டெப் வோல்டேஜ். ஸோ அடுத்தடுத்த ஒவ்வொரு பிட்டுக்கும் அதே அந்த ஸ்டெப் வோல்டேஜ் தான் இன்க்ரிமெண்ட் ஆகிட்டே வரப்போகுது, ரைட்? ஃபார் எவ்ரி இன்புட் காம்பினேஷன் sequentially the step voltage is going to be keep on accumulated, adding together, right? This is what the concept of the digital to analog conversion. Resolution. So we understand that what is resolution. So if there is only 3 bit, so another input here is reference voltage, right? So the digital input combined with reference voltage gives the analog output, right? Combined means in what way, in what is the manner in which it combines? See, the resolution is nothing but V reference by 2 to the power n, அதாவது reference voltage divided by 2 to the power n. 2 to the power n என்னது? What is 2 to the power n? The number of input combinations, right? See, digital input la எத்தனை bit இருக்கோ, suppose if there is n, if there are n bits, then 2 to the power n combination is possible. 2 bit இருந்தா 4 combination, 3 bit இருந்தா 2 to the power 3 8 combination, 4 bits na 2 to the power 4 16 combinations, right? So n is the number of bits at the input side, right? So your reference voltage is divided by 2 to the power n. So what do you get? That is your resolution, right? This is how you have to find the 1 LSB voltage or step voltage or resolution. The 3 term ஒரே meaning தான். 1 LSB voltage, ஒரு LSB inputக்கு எவ்வளவு outputல voltage, that means step voltage, ஒரு step தான் 1 LSB, that is called resolution also, right? So these 3 terms have same meaning, right? What is full scale output voltage? You also have to understand the next term, full scale output voltage. What is full scale output voltage, right? That is at the digital input when you have the maximum number. What is the maximum number? When all bits are 1. Full scale means when all bits at the input are 1. Say for example there are 3 input, all 3 bits are 1 at the input. What is the output voltage? Analog output voltage, that is called full scale output voltage. Understand? So that is full scale output voltage. அப்படி என்ன அர்த்தம்? மேக்ஸிமம் இன்புட் டிஜிட்டல் என்ன கொடுக்க முடியும்? எல்லா பிட் 1, எல்லா பிட் 1 கொடுக்கும்போது அவுட்புட்டில் எவ்வளோ அனலாக் வோல்டேஜ் வருது, அதுதான் ஃபுல் ஸ்கேல் அவுட்புட் வோல்டேஜ். எவ்வளோ வர முடியும்? அவுட்புட்டில் வர்ற அனலாக் வோல்டேஜ் வந்து டிபெண்ட்ஸ் ஆன் ஒன்லி த ரெஃபரன்ஸ் வோல்டேஜ் விஆர். விஆருக்கு மேலே வர முடியாது. அப்போ விஆர் வர முடியுமா? அதாவது ரெஃபரன்ஸ் வோல்டேஜ் அவுட்புட்டில் வர முடியுமா? முடியாது. அவுட்புட் வோல்டேஜ் அட் எனி பாயிண்ட் ஆஃப் டைம், output voltage when you give the maximum input will be less than the reference voltage, right. So, when you give the maximum input, that is full scale voltage at the output, when you give the maximum input, the voltage at the output is the full scale voltage which will be less than the reference voltage. So, this full scale voltage will be less than the reference voltage. புரியுதா? That is what full scale voltage, right. Now, what is percentage resolution? Resolution divided by full scale voltage into 100. So, resolution divided by full scale voltage into 100 is a percentage resolution. It can also be written as 100 by 2 to the power n minus 1, 100 by 2 to the power n minus 1. How does it comes? Resolution equal V reference by 2 to the power n, இங்கே பார்த்தோம், right. Full scale voltage is nothing but 2 to the power n minus 1 into resolution, right. Right. So, when you multiply these two, you get 100 by 2 to the power n minus 1. Okay. So, percentage resolution can be viewed calculated as 100 by 2 to the power n minus 1. What does it mean? Suppose இப்போ 3 bit data இருக்கு அப்படின்னா n is 3, what is 2 to the power n minus 1? n is 3, so 3 minus 1 2, 2 to the power 2 4, right. 100 by 4 is the percentage resolution, right. See, the full scale voltage is nothing but 2 to the power n minus 1 into resolution. அப்படின்னா என்ன அர்த்தம்? மேக்ஸிமம் இன்புட் எல்லா பிட்டும் ஒன்று கொடுத்தா அவுட்புட்டில் எவ்வளோ வோல்டேஜ் வருமோ அது ஃபுல் ஸ்கேல் வோல்டேஜ். எவ்வளோ வரும் அப்படின்னா ரெஃபரன்ஸ் வோல்டேஜிலிருந்து ஒரு ரெசல்யூஷனை கழிச்சா, தட் மீன்ஸ் ஒரு ஸ்டெப் வோல்டேஜ் கழிச்சா எவ்வளோ வருமோ அதுதான் வர முடியும். ஸோ ஃபுல் ஸ்கேல் வோல்டேஜ் வந்து ரெஃபரன்ஸ் வோல்டேஜ் கம்மியாக தான் வரும். எவ்வளோ வரும் அப்படின்னா reference voltage minus 1 resolution, right. Now, let us see what is resolution. I explained very clearly. Resolution என்னன்னு பார்த்தோம், என்ன பார்த்தோம், ஒரு ஸ்டெப் வோல்டேஜ், ஒரு LSB இன்புட்டுக்கு, டிஜிட்டல் இன்புட்டுக்கு அவுட்புட்டில் எவ்வளவு அனலாக் வோல்டேஜ் வரணும், that is resolution. See, for example here general formula for number of bits என்னன்னு வச்சுக்கலாம், என்ன number of output codes, அதாவது டிஜிட்டல் டு அனலாக் கன்வர்ஷனில் இன்புட் டிஜிட்டல் பிட்டு n refers to the number of input digital bits. 2 to the power n என்னது அப்படின்னா number of combination of the inputs, right. That means codes, number of code you can generate with n number of input. இப்போ டிஜிட்டல் டு அனலாக் கன்வெர்ட்டர் 4 bit டிஜிட்டல் டு அனலாக் கன்வெர்ட்டர் அப்படின்னு எடுத்துட்டா n வந்து 4, ஏன்னா இன்புட் வந்து 4 bit ஆஃப் டேட்டா கொடுக்குறோம், n வந்து 4. So, 4 bit of data, with 4 bit of data how many different possible combination of bits we can generate? 2 to the power 4. Why 2 to the power 4? Because the base value of binary number system is 2, right. So, 2 to the power 4 is 16 different possible combinations we can generate with 4 bit of data, right. So, what is the number of steps in the output? So, 16 different step நம்ம generate பண்ணலாம், but what is the outputல நம்ம எத்தனை steps வர முடியும்? 15. Why? So, இந்த 16ல 1 வந்து 0. So, when you give 0 volt as a input, when you give all bits 0 at the input side, இன்புட்டில் வந்து எல்லா பிட்டும் 0 கொடுத்தா அவுட்புட்டில் 0 வோல்ட் தான் வரப்போகுது. ஸோ அதை நம்ம கணக்கில் எடுத்துக்க முடியாது. ஸோ லெஸ் தேன் தட் ஃபார் 15 different input combination you will have the output voltage, right. So, percentage resolution is 1 by 2 to the power n minus 1. Step size P reference divided by 2 to the power n minus 1. So, if you understand this, you can also fill up this data, right. ஸோ இப்போ இந்த இடத்துல என்ன வரும் 4 bit டிஜிட்டல் அனலாக் கன்வெர்ட்டருக்கு இன்புட் வந்து 4 bit ஆஃப் டேட்டா 10 bit டிஜிட்டல் அனலாக் கன்வெர்ட்டர் input 10 bit of data. Inga with 10 bit of data, how many possible input combinations we can generate? 2 to the power 10. 1024 different input combinations we can generate at the input of digital to analog converter with 10 bit of data. Say how many number of steps in the output? -1, 1023. So like that you have to understand the spec. Speed, what is the speed? Rate of conversion of single digital input into its analog equivalent, right? That means digital to analog converter digital input pattern கொடுக்கிறோம், outputல analog voltage வரணும், கொடுத்த எவ்வளவு நேரத்தில் வரும், how fast this converter converts the input signal into the and generates the output voltage accordingly, that is speed, right? So naturally it is one of the important spec of the DAC. Obviously we would select the high speed DAC, yeah, because we need to convert the input data as far as fast, okay, possible. So conversion rate depends on what? Depends on the clock speed, settling time of the converter, right? So what is linearity is the another important specification of the DAC. What is linearity? Input is digital, in the digital to analog converter, input is the digital signal, output is the analog voltage, right? When you give different digital input combination, you get the analog continuous analog output. See, the output at any point of time, output voltage is proportional to the input sequence increment, right? So it is linear, output is proportional, linearly proportional to the input combination, that is why that is called linearity. Okay, now let me conclude that in our digital to, so far what we have discussed, the basic idea behind the digital to analog conversion and the specification of the DAC, digital to analog conversion, right? So in the next module we are going to discuss the actual circuit using the operational amplifier to convert the digital signal, digital input number into a analog voltage, right? Thank you.